Hello, BC Calculus. I am going to just show you how to access the Blackboard site. So what you want to do is go to my eBoard, and this is the only thing you'll see on my eBoard ever this year, but you will click on the link for the Blackboard, and you'll get what we will call my home page, and you're going to click on the BC Calculus link. And for right now, this will all change, but for right now, you need to browse as a guest because I don't know how to enter. I don't have a roster yet, so we'll wait on that. But what you would like to do is click on Lessons, and you'll notice that if you go to BC Calculus Week 1, there's something called Practice and Homework, and this is a whole bunch of quizzes that you might want to take just for fun. I am having technical difficulties, so right now I cannot see your preliminary quiz on Chapter 1 and your limits and derivative review number 1. So this is just for you, again, technical difficulties. If you go back to lessons and okay, back to this, let's look at summer packet information, because this is what we're going to focus on sort of outside of the classroom right now for a little while for practice. And in fact, you're going to post your summer packet answers right here. So eventually what you will do is select some of these summer packet answers. And I'm going to get started. So I'm going to I'm going to choose 30D because it's an especially hard problem, because it'll be good for me to demonstrate that. So I'm going to edit wiki content, and so I'm just doing 30D. Okay, and for 30D, we're looking for the derivative of cube root of x. So in order to type in these math symbols, we have this handy little f of x button. And I know I'm going to use a limit, so I'm going to click on this little box, and I'm going to write LIM. Okay, h is approaching 0. And then we need to add a fraction, a difference quotient, obviously. So I'm going to come here, I'm going to add a fraction, and we know that we're going to have the cube root of x plus h, cube root, minus the cube root of x. I'm just following the limit derivative definition over h. Okay, so there's our start. Obviously, we need to do a little bit of work here. We have the difference of two cube roots. We need to get rid of those. So we all know the only way to do that is to multiply by, not even the conjugate. You need to remember that formula for factoring perfect cubes. So I'm going to multiply by the cube root of, I'm going to have x plus h squared, right, cube root of that. And then we're going to have plus cube root of x plus h times x. And then we're going to have plus again, and we're going to have cube root of x squared. And this is the hardest part of the whole problem. And we're going to multiply by this on the top and bottom. So I'm just going to copy, and the normal Apple C, Apple V. Sometimes you have to do it twice or just wait. Okay, there we go. Good. Didn't mean that. Pays to be patient. Okay, now here's what we're going to have. We know the next line is also just going to be a simplification of this one. So I'm just going to do a lot of copying. So I'm going to come down to my next line. Let's just wait. We should get that limit statement again. Okay, there we go. And I'm going to take the limit of, limit of, and I'm just going to simplify this fraction. We know that when we multiply the top and the bottom, or when we multiply this binomial times the trinomial, we're just going to be left with x plus h minus x. And on the bottom, we're going to have this whole pain in the neck thing. So I'm going to copy that. On the bottom, I'm just going to type in h, and then we're going to have brackets, right? And then I'm going to put in that whole thing. Just wait for it. Okay, there we go. once again, I need to be more patient. Okay, and now let's clean this up. Now let's fix this. So our next line again is going to have the limit statement, because that always is an inherent part of a derivative definition. We're still stuck with a fraction. On the top though, we're just going to have h, and on the bottom we're going to have this entire package, this entire denominator. And then when we cancel out our h's, we're still going to be taking the limit as h approaches 0. But we're just going to have a 1 in the numerator. So I'm going to have a fraction, and we're just going to have 1 over this thing. Put that in. And now we can take the limit as h approaches 0. Clearly we're going to be left with just a plain old fraction. You know that in the numerator we're going to have a 1. In the denominator, though, this h is approaching 0. So we're just going to have the cube root of h squared. And then we're going to have plus the cube root of h squared. X squared, sorry. And then we're still going to have plus another. In fact, I'm just going to copy this over. Which we can then simplify as just fraction again, 1 in the numerator, and in the denominator we just have 3 of those things. So I'll just copy that. And there's our derivative. So I will accept that. In fact, I'm going to clean it up a little bit. I'm going to, I would like to put another, okay, I'm just going to accept that. It'll take a minute. And there is the solution to 30D, or the solution. There's the derivative. I'll click Submit. And that's there forever. So if somebody this evening wants to put down his or her answer to 30E or 30F, that would be great. Oh, and you can also comment on it. Like you might want to say, "Nice job, Ms. Sweeney." Okay, and it goes without saying we're going to be nice. So thanks. Hope this helped. We'll talk tomorrow, and I would like your feedback. Thanks.